Okay guys, so here I have my stepper motor driven balsa wood cutter that I'm going to be working on in the next few weeks. Basically what it consists of, a stepper motor driven by a gear train on a rubber roller that is being pressed by another softer foamed rubber. It's almost like more of foam than rubber, but it's being pressed down by that with these aluminum sides, so I can accommodate for different thicknesses of balsa wood. And what I have running this is a Arduino Mega with a Seed Studio stepper motor controller. It's actually just a motor controller, but you can run one single two-phase stepper motor off of it. And I have that running just a random pattern back and forth with different steps and speeds. What I'm going to be adding with this is a motor that is a really geared down. It's 24 volt. It's got a quarter-inch square shank hole, so I can put a quarter-inch square shaft through and build off of that. What it's going to do is be mounted probably somewhere right in here, close to that, and then I have, or going to be making a cam type axle on here that'll be riding in a slot back and forth, and this is what's going to house the razor blade down here. And I got to make a little block that'll hold this on the base, and that cam will be riding in here, and while it goes around in a circle, will be cutting. And on this, it's got a micro switch which has a flat spot on the shaft. Right there, you can kind of see it. And what this will do is when I run my program, it'll be able to see every time when this micro switch gets in that flat spot. And I'm going to be hopefully finding one of the transistors in my junk drawer that will be able to power this, or switch the transistor on with my Arduino, and also be able to, I want to run this off of 24 volts, but I might have to go down to even 12 or 9 volts due to the transistors. I haven't looked of what all they can, the low power switching that they can do, so you can run them off Arduino or not. But I want to run it off of 24 volts, so that's what they're rated at. You could go up higher, but you don't really want to be burning up the armature inside. But I'll be running it off of 24 volts, therefore I can get the fastest speed out of here. And that'll be mounted down here. And with my program, I need to find how many steps it takes to get through the rollers and go past the razor blade. So when it starts the program to be cutting the balsa wood, it'll go past, cut it, clean off the end, and then also make that your 0 mark. So then from the razor blade, it'll measure out from there of your steps for your distance of your piece you need to cut. I'm going to be making 2 programs. My first program on here is just going to be, you type in a number of centimeters distance-wise of the material needed cut. First it would be, like I said, be zeroing it out, cut it, and then you type in the distance. And then what that'll do is it'll calculate how many, or from the distance that you typed in, it'll calculate the steps it needs to take to get your material through to that within hopefully a few thousandths. Not that you need it that thick for building, but just something I can brag about at the end. And it'll do that, and then it'll click on that transistor that I'll be putting in, cutting the material off, and then you can be able to type in another number. I'm not quite sure, I haven't figured out how many inputs I can take or want to take at a time, so you can type in all your stuff and then go do something while this is over here cutting all your pieces. The second program will be once I figured out the devices I need to do multiple variables with. I'll be able to measure all my material out and then just input it into the program itself and then save that file. So all I have to do is just put a 4-foot long chunk of balsa wood and it'll just keep on cutting through the whole entire software. As you can see, I have a roller here that's in a little slot, so I can press that down. I was going to do spring-loaded on here, and then I decided it wasn't necessary due to the soft foam of this. And then I was going to find a type of bearing or sleeve that I can put in there to help the not create so much drag on the motor, but that doesn't seem to be the issue with this. When I was testing last night, I would do about 50 steps, and then I put my dial indicator on the end of the ruler, and the dial indicator it really surprised me of how accurate that this motor can step out. I was doing 50 steps, and it was almost a half an inch back and forth, and within that half an inch, it was only like a quarter of a thousandth or a quarter of a thou air every time it would come over, and that's mainly due to the backlash. And considering a quarter of a thou, considering that an average printer paper is almost 4 thousandths thick, which is pretty incredible of how accurate I could possibly get this. The main problem is calculating that backlash a little bit, and then calculating how many steps are actually in a centimeter, or if it will be accurate, or if it'll come out to a half step or what. But that'll be the fun part, and figuring all that. With the Arduino software, I need to figure out how many steps per one revolution of this motor is, to program it in there so I can get an ideal stepping speed for the motor, so I don't overstep it. Because if you overstep it, basically a stepper motor has coils inside it that it's not like a regular DC motor, that it's got an armature and it'll spin past or spin a certain degree, and then the polarity on the armature will switch polarity and then attract it to the next magnet next, and so on while it spins. A stepper motor just has coils and magnets that are permanent in there, or vice versa. Magnets, or the coils, are probably permanent, and then the magnets spin around on the shaft. What you do is when you pulse it, it attracts it to that magnet, and then it pulses the next phase of winding, and then keeps on going back and forth, so you pulse it really fast. Well, the problem is if you don't have a very large number of steps per revolution, you can't step it very fast, otherwise you're stepping it and then changing to the next coil before it actually physically moved. So you just get this vibrating of your axle in there, and it doesn't seem to do anything. And sometimes if you find the limit of it, like I did one night, I put, supposedly on my program, it was 130 revolutions that it seemed to come out to be, but I haven't calculated the number of steps in the motor itself, so I couldn't actually calculate that for sure. But it was just, it would go, and then eventually some spots you can hear it stepping, but your material wasn't moving through. So you just have to be careful about that. So I will plug this in and show you just a quick little demo of the different step speeds and distances. Let me move this over here quick, somewhat in the center, so I don't run off. So I'll back this out so you can get the full idea of what's going on. So right now it's running very slow, probably 50 steps now, and then it goes to 100 steps. Right now it's 100 steps, and then it does 1,500 steps, and then 3,000 goes back to the other side of the ruler, and then a negative 1,500 steps to the back of the center. And right now that's probably about the fastest feed rate I could get out of this, to be accurate with it, not double stepping with the motor. So you can kind of get a good idea of what's going on. And with these cables, I gotta cut a slot in here so I could, put longer standoffs on there to actually help guide the material through, otherwise it'll come off the roller. Like that, it'll be coming off a little bit. Got to make a guide right in the center to help hold that in there. Like I said, this was a label maker roller and stepper, and these wires go to an encoder down there that it sees the whole slot, hole or slot, depending on what kind of label maker you have. But this was a slot, and it sees that there's a slot in there and mark 0. And so every time you can get it at the tear off. But Let's get an idea. So it's very, very accurate. So hopefully in the next week I'll be able to get my motor mounted in here, and I think maybe after Friday I'll be able to get the circuitry done and have this thing fully up and running, depending on how busy I am this week. But it'll be really cool to have this just be building your device for you, I guess. I also might even solder in a little circuit or control panel board that will have like a arcade type potentiometer like they do in video games, controllers for like Xbox or something, and I might have that, and might make a separate program for this, just because I don't want to have it over complicated if someone needs to change something in my program if there's something wrong. But I'll have that so you can do it manually. So you can just have a set distance of what you want on the board itself. So if you put a stop block or something to mark it there, you could run it out, hit that, and then you can cut it off just by pressing a button and repeat it very easily. But I think it'll turn out pretty cool. It might be slow, but at least I don't have to do the work. See the stepping of the LEDs. So it's doing the fast speed right now. Now come back over. So it's actually stepping it really fast right there. You can see the steps, how fast it actually goes. And it changes speeds. So all in all, it'll be pretty fun to build. So if you have any questions, give me a comment below. I'll try to answer them bestly as I can. But I think it'll turn out pretty well.